In section 8.5, we're going to talk about angles in a circle. So we're mainly just going to focus on two different types of situations here. First one, let's say we have a circle and we have two lines drawn like this. And let's say that for whatever reason we wanted to find out what that angle measure was. The relationship here, if we look at this arc that was created by the two lines of the angle and this other arc that we'll call y, the relationship every time would be that the angle equals half of the two arcs added together, okay? Here's a different kind of situation. So let's say I have, again, two lines drawn through a circle, but now that angle's on the outside of it, and I want to find that angle. If I look at the bigger arc there, which I'm going to call arc X, and the smaller arc closer to the angle, which I'll call arc Y, the relationship here is that the angle is half of the bigger arc minus the smaller arc. One way to kind of remember the difference between these, the inside angle, so if like the angle is made on the inside, I would add them. And if the angle is formed on the outside of the circle, I would subtract. And another way to kind of remember what to do between the two of them, if I have an angle that's kind of smushed to the inside of the circle, it's going to be a wider angle. But if I kind of stretch it out, going back to that slingshot analogy, if I slingshot it out, that angle is going to get more narrow, so it's going to be smaller. So smaller you would subtract, bigger you would add. So let's look at two examples. Here I have this diagram and I want to find the value of x. I can see that that's an inside angle, so I'm going to add the arcs, cut them in half. So to find x, I would do 1/2 of 46 plus 90, which is 68 degrees, and that would be it. Now let's look at another example. Here I'm given that I have that angle of 20 degrees and I want to find that minor arc there, x. So I can see here and recognize that this is an outside angle. So I'm going to set that up this way. So I know that the angle is equal to half of the bigger arc minus the smaller arc. So I'm going to set this up by going 20 equals 1/2 times 95 minus x. The bigger arc is always going to be the one furthest away from the angle as well. And then to solve this, an easy way to get rid of that fraction is to multiply by the reciprocal. So I'm going to multiply both sides by 2. That's going to cancel out that 1/2. So now I'm left with 40 equals 95 minus x. I subtract 95 on both sides. Now I have negative 55 equals negative x. If you have a negative on both sides, you can just cancel them out. So I'm left to know that x is equal to 55 degrees, and I'm done.